Alrighty, hello everyone. Welcome to part 2 of the section 3 lecture series for mathematical proofs. So now we will start covering proof techniques, and we will start with trivial proofs. So, trivial proof. If you recall from section 2, we looked at implications. Most implications encountered will be open sentences. So, if you can recall the truth table for two open sentences with an implication. So let's draw out that truth table. So we have our two open sentences, we have our implication, so we'll have four different possible combination, or four different columns. So we'll put in our truth values here. So if you recall, an implication is only false whenever the open sentence px is q and qx is false. Otherwise, it's always true. But for a trivial proof, if qx is always true, then the implication is true. And also, likewise, if px is always false, the implication is true. And you can scroll up and look in this table. So if we look at all the truth values of these statements. So when qx is always true, then the implication is always true, and likewise when px is always false, the implication is true. So now we will look at what a trivial proof is. Let me rewrite that. So trivial proof is a proof where we can prove a statement which is often an implication by determining the truth of the open sentence being implied. In other words, when QX is always true. So, an example. Say we're given a proposition. So, let X be an integer if 3x plus 12 is greater than 0 is positive, then 6x minus 18 greater than 0 is positive. So, for writing proofs, before you begin writing, sometimes it can be beneficial to write out a proof strategy or to show some scratch work, as even if the reader doesn't want to read this, they can still understand your logic from the proof. But this can help someone if they want to see more in-depth reasoning into your proof, then they can look at this. So we're going to do this for this example. I won't do this for every proof that we do, but we will write out a proof strategy here. It appears we can prove this trivially. So we can separate this into two open sentences. Px 3x plus 12 less than 0 is positive, and also Qx 6x zero. We're going to draw that. Positive. To prove this trivially, let's solve for x in Qx and show it is true for all x. That for all integers x. If you recall this diamond symbol from, symbol from when we did the examples. Sometimes it's used to show the conclusion of a proof strategy too, which I don't know why I'm being sloppy at getting this one made. There we go. All right, now let's write our proof. So, if you recall, we need to begin with the section title. This will be where we'll begin writing our proof. So, we'll first start by defining x as an integer. Then we will say if 6x minus 18 is less than 0, then we'll just move that over. Then this implies that x is greater than 3. So hence 6x minus 18 less than 0 is positive. So therefore the statement is true trivially. And we have just proven this statement using a trivial proof. Because we have showed that the statement qx is true for all integers x that it is positive. So, therefore, if we go back to our truth table, the implication is true. And this is an example of how you write a proof, keeping the words to a minimum and letting the logic explain how you evaluated or how you have proved this. This was a proposition. So, yep. And then the implication symbol, remember, this is involving logic because we can logically deduce that we can divide by 6. So this is a time when you can use a logical symbol in a proof and in mathematical writing because it is discussing logic right there. All right, so that's it for trivial proofs. Now let's switch over and change colors here, and now we will look at vacuous proofs. So what is a vacuous proof? Well, a vacuous proof is a proof where we prove a statement by sorry, I was trying to fix that E there. By showing the falseness of the open sentence that is the implier, which if we were looking at the, well, let's actually not. If we were looking at the example above, we would say that px is always false. Because going back to the truth table, that implies that the implication is true. So, an example. Let's look at this proposition. Let's let x be an integer if 8x plus 48 is less than 0 is positive, then 0 is less than or equal to x, which is less than or equal to 6. So Let's write out our proof strategy. So we will proceed to prove this vacuously. Let's break the statement into two open sentences. So let's start with px. 8x plus 48 is less than 0 is positive, and qx 0 is less than or equal to x, which is less than or equal to 6. So we can solve for x, and 8x plus 48 is less than 0 to show it is false for all x, for all integers x. All right, so let's write our proof. So start by defining x, let x be an integer. So if 8x plus 48 is less than 0, then 8x is less than negative 48. So this implies that x is less than negative 6. So hence 8x plus 48 is less than 0 is positive, is false for all integers x. So therefore the statement is true vacuously. All right, so that's it on trivial and vacuous proofs. So the last thought I will leave you with for this lecture is that both trivial and vacuous proofs are rarely encountered, but they proof techniques and help us understand implications and the truth behind them. Which, of course, that's using truth tables. All right, so yeah, that's it for this lecture. So I'll just draw out some fun little doodles here. So we have covered trivial proofs. Draw a question mark here because I like think of this like a quiz show. I don't know, when I think of the word trivial, I think of the word trivia, so, and I wanted to make an arrow. And then for vacuous proofs, we will draw a vacuum cleaner. It is the proof vacuum. It's the proof vacuum, and we'll draw, it's like one of the little hose vacuums with a little brush attachment at the end. And just make it look like an advertisement. This is making a clean room for the truth of a proof. Just some fun little doodles that I wanted to share. Just to make these lectures seem a little less boring. Alrighty, so, hey guys, that's it for part 2 of section 3. Thank you so much for watching, and I will see you in part 3 of section 3.